going to look at now geometric sequences and series. You have done just the general sequences and series, and now last time you looked at arithmetic sequences, which you added a common difference to get to the next term, and now we're going to look at geometric sequences and series. So, as it says up here, you looked at the arithmetic sequences, you added you got a common difference to get to the next term. Now we're going to look at geometric, which is a common ratio. In order to get from one term to the next, to the next, to the next, now we're not adding or subtracting something, we're actually multiplying by a number. So the common ratio is R, that's what the R stands for. And the way you get R is just take A2 divided by A1, or A3 divided by A2, or you just take the next term divided by the previous term and you get that R value. Okay? And that R value can never be 0. If you have that, then obviously you just have 0, 0, 0, 0 as your sequence, which would not be really much of a sequence. Okay? It says down here, the nth term of the geometric sequence is always in the form of a sub n is equal to a sub 1 times r to the n minus 1. And we'll look at this more in detail in a few minutes, but that's because if you just take from one term to the next term to the next term to the next term, all you do is multiplying by r. Take that first term, multiply it by r. Take that first term, multiply it by r twice, or r squared. Take that first term times r gets that, and so on, so on, so on. Okay, so let's look at an example and see how this works. It says, what are the first 5 terms of the geometric sequence whose first term is a sub 1? So we know the first term, a sub 1, is 2. And the common difference is r equals 1/2. Okay, so plug it in that form of a sub 1 times r to the n minus 1. That's the form we're going to use. Okay, take your first term, multiply that by r to the n minus 1. 2 minus 1 is 1. So 2 times 1/2, of course, is just 1. The third term, take the first term, multiply by 1/2. But now, how do you get from the first term to the third term? You got to do it twice. So that's where you get your 2 there. So 1/2 squared is 1/4. Times 2 is 1/2. A to the 4th is 2 to the 1/2 times 2 times 1/2 to the third power. 1/2 times 1/2 times 1/2 is 1/8 times 2 is 1/4. And then a to the 5th, a sub 5, the 5th term is 2 to the 1/2. 2 times 1/2 to the 4th power. And when we multiply all that out, you get 1/8. So there is your sequence. 2, 1, 1/2, 1/4, 1/8. Example number 2. What is the 17th term of the geometric sequence if the first term is 12 and the common ratio is 1.02? So we're going to look at that general form that a sub n is equal to a sub 1 times r to the n minus 1. Okay, so let's plug in what we need to have right here. Okay, we know the 17th term. That's what we wanted to find. Now, if I take that first term, how many r's would it take to jump from 1 to 17? It would take a total of 16 there. So what I'm going to do is I'm going to say that 17th term, the first term is 12. My r is 1.02 to the 16th power. Just simply type that into your calculator and you're going to get, let's round that to the nearest hundredths, it would be about 16.47. Now we're looking at example number 3. What is the 10th term of the geometric series 1, 3, 9, 27? So remember we want to find our common ratio first, our r value. Okay, and you do that by taking one term and dividing by the term just before it. So you can do 9 divided by 3, or you can do 27 divided by 9, or you can do the first and second one, which is 3 over 1. All those reduced down to the same exact number of 3, because you just simply multiply by 3 to get the next term. So if I use that general formula that we've been using, a sub n is equal to a sub 1 times r to the n minus 1, we're wanting to find the 10th term. The first term is 1. R value is 3. From the first term to the 10th term, you take 9 jumps. Okay, So if I take that, plug it into your calculator, because I'm not about to do that in my head, 19,683 is what that 10th term would be. Example number 4. If the second term of the geometric series is 4 and the fifth term is 1/16th, what would be the ninth term? So this one's a little bit different. Okay. So the first thing I'm going to say is let's find our R value. So I know the second term and the fifth term. So let's look at that. Let's look at the fifth term. If I look at the fifth term, I'm going to take the second term and do how many R's would it take to jump from 2 to 5? You can just do 5 minus 2, or simply know that's 3. So let's plug in those values that we know. The fifth term is 1/16th. The second term is 4. And that 5 minus 2, of course, is 3. So divide by 4 or multiply by 1/4 is what I would do. Because we have fractions, that is 1/64 equals R cubed. And then we take the cube root of both sides. And the cube root of 1/64 would give you a value of 1/4 for R. Okay, now that's not done yet because we are not all the way to what says what is the ninth term. Okay, a couple of ways you can do this now. I would just simply say, well, let's start where we left off, the fifth term. Okay, and we want to find the ninth term. If I start with that fifth term, how many jumps would that be from 5 to 9? That, of course, would be 4 jumps. So I don't know my ninth term. That's what I'm trying to find. I do know the fifth term is 1/16th, and that R value now is 1/4. So I would use your calculator to make life a lot easier here. And that's going to go to 1/4096. Now we're going to take a look at the sum of a finite geometric sequence. So it says over here, it says for the finite geometric sequence, of course, the pattern that we're looking at, R cannot be 1. If you do this, you use the sigma notation. Of course, the lower limit, upper limit, and what we're finding the sum of is the geometric sequence. You can do this formula here, take the first term, times it by 1 minus R to the n, or the ratio to the nth power, and 1 minus R. So let's look over here and see what we have. See, I put this into use here. So find the sum from x equals 1 to 10 of 2x. So if I'm using this formula here, I got to know what the first term is. So let's figure out what the first term is. A sub 1, because it starts with 1. So 2 to the first power is 2. Okay, so got that taken care of. Now I've got to find the r's. Okay, the r is just the common ratio. So let's find the second term and the third term just so that we know what we're doing here. Second term would be 2 squared, is 4. Third term would be 2 cubed, which is 8. Obviously, you can see that our common ratio is going to be 2 to get from 2 to 4, 48, so on, so on. Okay? And our n value is going to be whatever it is up here. How many terms we're looking at from 1 to 10 is 10 terms. Okay? You always got to make sure you start where it's saying from 1 to 10. If it's like from 0 to 10, that would be 11 terms. But we're only doing from 1 to 10, so we're good to go there. So let's plug it in. A sub 1, 1 minus r to the n over 1 minus r. So we're going to plug it into. The first term is 2. 1 minus 2 to the 10th power over 1 minus 2. And if I use the calculator for that, you get negative 1023 over negative 1, which just goes to 2046 as that answer there. Right. Now we're looking at geometric series. If you want to find the sum of an infinite geometric sequence, that is called a geometric series. Since, if you think about it, since we want to add up something that never ends because it's infinite, it's kind of hard to do that. But we can do that if there's a certain thing happens with the r value, the common ratio. If the absolute value is less than 1, then we can do it because it gets closer and closer to 0, and eventually the number kind of just disappears there because it gets so close to 0. So when that happens, we can use this formula here. You can see how everything works here, and the main part is a sub 1 is equal to 1 minus r. Okay, so let's go see how this will actually work. So we look at the lower bound is 1, upper bound is infinity of 2 times 0.8 to the I power. So let's just think about what the first few terms would look like. Okay, if I plug in, the starting value is 1, so if I plug in 2 times 0.8 to the first, plus 2 times 0.8 squared, plus 2 times 0.8 cubed. You're going to do that forever and forever and forever, okay? Because that's what infinity means, obviously. Okay? But all we need to know is how do we get, what's the first term? Because remember the formula is a sub 1 over 1 minus r. Okay? So if I think about that formula, the first term would be this value right here, which is just simply 2 times 0.8, which is 1.6. And the r value, how to get from one term to the next is just simply that 0.8, that term right there. So 1 minus 0.8. And if you do that, you come up with a value of 8. Would be this. Okay, now let's put this to use with an application type problem. It says you want to start to save money for retirement. You have found a mutual fund that you can invest in to accumulate your retirement fund. Start that again. Now let's look at an application problem for the geometric sequences series. It says you want to start saving money for retirement. You have found a mutual fund that you can invest in to accumulate your retirement fund. The interest rate is 12% and is compounded monthly. You deposit $100 per month into your account. You will retire in 40 years. What will the balance of your retirement fund be at that time? So, putting $100 in a month, not bad. Let's see what would happen if you actually start that when you're young, and in 40 years, what would happen? How much money do you think you'd have? Okay, so let's just look at a few things here. Let's look at the first deposit. The first deposit. Okay, one thing that you have to remember is first let's look at the formula for compound interest. When we look at the formula for compound interest, the accumulated amount is equal to the principal times 1 plus the interest rate divided by n, which is your number of times it's compounded in a year. Number of times it's compounded in a year times the number of years. Okay? So looking back now at your first deposit, okay, I put in $100, the first $100 deposit. Okay? If I use that formula right there, let's see if I can scoot that over here real quick. Nope. Yep, there we go. Kind of get that, scoot that over the way. So, the first deposit of $100, okay, I put in $100. The interest rate is 12%, so 0.12. It's compounded 12 times in a year. And how long is that first payment going to be in there for? It's going to sit in there for 40 years. So, you're 12 times 40, right? Which, of course, would be 100 times 1.01 to the 480th power. And you can, use a calculator to figure out what that is. Okay. The second deposit of $100, it would sit in there almost the same amount of time, right? But instead of all 480 months, it's only going to sit in there for 479 months because you waited 1 month to put that in. So obviously that is 100 times 1.01 to the 479. Okay, we can do all the way down to the very last deposit. And the last deposit would be 100 times 1 plus 0.12 divided by 12, and only sits in there for 1 month, right? Okay, so we can kind of see the pattern that's made here, right? So let's start by figuring out what our sum is going to be now. Okay, so let's say the sum of the first 480 terms, because we're doing it for 480 months. Okay, and we're going to use that summation formula. Write that over here. The sum of the first terms is going to be the first term times 1 minus r to the n over 1 minus r. That's what we're going to use here. Okay, so the first term, now we're going to think about what is our first term in this sequence here. Okay, the first term, which is really our last term because that's the one that stays in there the shortest amount of time. If I figure out this right here, that just is $101. So that is actually my first term. Kind of have to go backwards in the thinking there. It's not the big number, it's the smallest one. It's the one that's only in there for the first month. Second term would be the one that's in there for 2 months, 3 months, 4 months, so on and so on. Okay? And 1 minus, if you tell our R value here, I forgot my 1 there, the R value is 1.01 because that's how much it changes by each time, right? So 1.01. Now the N is, we're doing it for 480 months over 1 minus 1.01. And when you use your calculator, because you're going to get a nice humongous number of, get ready for this, 1,188,242, and don't forget your 2 cents. That is quite a bit of money if you do $100 a month for 40 years at 12% interest. Okay?